Okay, so just a very quick recap of what we mean by homozygous. Homozygous is where they have two alleles that are the same, so homo is the same. So you could have homozygous dominant, which is where they have two dominant alleles which are the same, or two recessive alleles which are the same. And remember, what dominant means is that if you have a dominant allele, then that is the characteristic which will be shown. Whereas a recessive allele, you need two recessive alleles to be able to show that characteristic. Heterozygous means where they've got two different alleles, and of course there's only one combination. So they have one dominant and then one recessive allele. Now, the reason why I've just given you that as a quick recap is because what you need to be able to do is be able to apply this and be able to use this to determine and work out the probability of a child having a particular disorder. Now what this is a punnet square. You just do 2 lines down, 2 lines across, just like you were doing noughts and crosses. So this is a punnet square. Now you will get a typical question which is like this. So Kate is heterozygous, Sam is homozygous recessive. What is the chance of them having a child with cystic fibrosis? And of course cystic fibrosis, which we'll look at in the next section a bit more detail, is a recessive disorder. So in other words, the child would need to have two recessive alleles to be able to show that. Now what it's expecting you to be able to do in this question is understand what you mean by these, and of course be able to apply that to work out the probability. Now on these punnet squares, each one of those squares is going to be worth 25% each. Now what you do here is you put what the parents' alleles are here, so the mum's alleles and dad's alleles. It doesn't matter which way round you do them, you still get the same answer. So Kate is heterozygous. So if we go back to what heterozygous means, she's got two different alleles. Another key point here, if they tell you to use a certain letter in the exam, you must use that letter. So for this one, I'm telling you that you should use Fs. A capital F for dominant, a lowercase f for recessive. So Kate is heterozygous, so therefore she has got a dominant and a recessive allele. The dad is homozygous recessive, so that means that he's got two recessive alleles. So to work out what this child would have, you just put the allele from the mum there, allele from the dad. So that child therefore would be heterozygous, so it would be a carrier of cystic fibrosis, but it wouldn't necessarily show it. Its phenotype would not show that characteristic. This child, again, would be a carrier, it would be heterozygous. Now this child would be homozygous recessive. So what that means is that child would show the characteristics of cystic fibrosis, and so would this one too. So there would be 50% chance of the child having cystic fibrosis. So each one of those squares was worth 25% each, so that's 50% in total.